In this video, we will graph sine, cosine, and tangent functions and some basic transformations. To start off with, let's talk about some vocabulary for periodic functions. A periodic function is a function that repeats a pattern of y values or outputs at regular intervals. One cycle is one complete pattern of that function. So in the graph shown below, this would be one cycle. The period of a function is the horizontal distance or length of one cycle. So in this case, the period would be 4 units. The amplitude is half the distance between the maximum and minimum values of a periodic function. So in this case, the amplitude would be 1/2. The maximum value in this case is 2. That's our maximum y value, minus our minimum y value, which is -2, and that's 1/2 of 4, which is 2. Another way to think of the amplitude is the distance from the midline of the function to the top or to the bottom. So the midline is the horizontal line in the middle. And the distance from the maximum value to the midline is 2. Or we could do the midline to the minimum value, which is also a length of 2 units. So that is another way to think of the amplitude. Now we're going to graph our sine and cosine graphs. We're starting off with sine. To complete a table for the function f of x equals sine of x, we're going to use the values from the unit circle that we have previously learned. Sine of -pi/2, if you think about the unit circle, -pi/2 is coterminal with 0 and 2 pi. And the sine at that point, or the y-coordinate, is 0. Sine of -3pi/2, -3pi/2 would be coterminal with +pi/2 up at the top of the unit circle, and the y-coordinate at that point is 1. -pi is coterminal with pi, and the y-coordinate is 0. -pi/2 is coterminal with 3pi/2. Down at the bottom of the unit circle, the y-coordinate is -1. Sine of 0 is 0. Sine of pi/2 is 1. Sine of pi is 0. Sine of 3pi/2 is -1. Sine of 2 pi is 0. And this pattern would continue. If I added on sine of 5pi/2, I would get 1, and so on. So let's plot these points in the coordinate plane. I'm going to start in the middle with my point 0, 0. So a sine graph goes through the origin. At pi/2, the y-coordinate is 1. At pi, it's 0. At 3pi/2, it's -1. At 2 pi, we're back to 0. And I'm going to plot the points on the left-hand side. Sine of -pi/2 is -1. Sine of -pi is 0. Sine of -3pi/2 is 1. Sine of -2 pi is 0. And we have this periodic function that would continue to repeat that cycle. So we could draw some arrows to indicate that it will keep going. The domain of this function, since it does keep going to the left forever and to the right forever, is all real numbers, or -infinity to infinity. The range, our lowest y value is -1, and our highest y value is 1. The period of a sine function, the length of one cycle, if we start at the origin, one cycle is getting back to that same starting point, and the length of that one cycle is 2 pi. In general, to find the period of a sine or a cosine function, you're going to use the formula 2 pi over b, where b is the coefficient of theta. The amplitude of this function is the distance from the midline to the top. That's 1. Also, the amplitude is going to come from the a value, the absolute value of a. So the absolute value in this case of 1 is 1. And the intercepts of this function touches the well, let's talk about the y-intercept first. The y-intercept, it goes through the origin, 0, 0. The x-intercepts, well, there's lots of them. We have negative 2 pi, negative pi, 0, pi, 2 pi, and that pattern would keep going in both directions. So the way we could express the x-intercepts is x equals pi k, where k is any integer. So any integer multiple of pi would be an x-intercept for this graph. Now we're going to graph our cosine function. We'll start by completing a table like before. If we think about our unit circle, and we've got 0, pi, 2 pi, that would also be negative 2 pi. At the top, that would be pi over 2. It's also coterminal with negative 3 pi over 2. On the left side, we've got pi. It's coterminal with negative pi. On the bottom, we have negative pi over 2, or we could think of that as 3 pi over 2. So cosine of negative 2 pi is the x-coordinate, which is 1. Cosine of negative 3 pi over 2, the y, or the x-coordinate again, is 0. Cosine of negative pi is negative 1. Cosine of negative pi over 2 is 0. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. So now if we plot those points, negative pi over 2, 1. Negative 3 pi over 2, 0. Negative pi, negative 1. Negative pi over 2, 0. 0, 1. Pi over 2, 0. Pi, negative 1. 3 pi over 2, 0, and 2 pi, 1. It looks similar to our sine graph, but instead of going through the origin, its y-intercept is 1 unit up, or at the point 0, 1. But the shape of the graph looks similar. This time, our first cycle, if we start at x equals 0, starts up 1. And then it still has a period of 2 pi, but it just begins in a different place if you think of that as one cycle. So the period, or the length of one cycle, is still 2 pi. The domain of this function is still all real numbers. It will keep going, keep squiggling to the left and to the right, so negative infinity to infinity. The range for this function is also negative 1 to 1. The period is 2 pi. And again, we're going to use 2 pi over b to find the period in general. The b is the number in front of the independent variable. In this case, since we're just doing cosine of x, our b is 1, and 2 pi over 1 is just 2 pi. The amplitude, again, we're going to do the absolute value of a, or the coefficient of the trig function, the sine or the cosine function. And in this case, it's 1. Absolute value of 1 is 1. And we can also think of that as the distance from the midline to the maximum value, or the distance from the midline to the minimum value, which is 1. And the intercepts for this graph, the y-intercept is going to be the point 0, 1. The x-intercepts, well, this graph touches the x-axis at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and that pattern would continue. So the distance between each x-intercept is 1 whole pi. So we could express these x-intercepts as pi over 2 plus pi k, where k is any integer. Now we're going to do some examples of graphing sine and cosine functions that have changes in their period and amplitude. So remember, in general, y equals a sine of bx, or y equals a cosine of bx. The amplitude is going to be the absolute value of a, and the period is going to be 2 pi over b. So let's start with the period for this function. Since in this case there's no number in front of x, b is just 1. So if we do 2 pi over 1, we just get 2 pi. So that period hasn't changed from our original sine graph. The amplitude of this function is going to be, from that a value, the absolute value of 2 is 2. So the distance from the midline to the maximum value or to the minimum value is going to be 2 units. So when you graph your trig function, since the period is 2 pi, I'm going to label my axes, and you want to have, if you're using graph paper, you want to use 4 boxes for one cycle. So I'm going to label this fourth tick mark 2 pi. In the middle of that, I would put 1 pi, half of that. Half of pi is pi over 2. And so each little section that I have here represents pi over 2. So let me erase this. So I've got 1 pi over 2 right here, and then 2 pi over 2 is pi, and this would be 3 pi over 2. And then we label the left-hand side negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And then on our y-axis, we're going to label, I'm going to count by ones. 1, 2, 3, negative 1, negative 2, negative 3. It's very important to label your axes. Okay, so now for a sine graph, we start at the origin, 0, 0. Normally, I would go over to pi over 2 and up 1, but since my amplitude is 2, instead my maximum point needs to be up 2. And then I go back down to the x-axis at pi. Since that y-coordinate's 0, it doesn't change. And then my minimum value, instead of being negative 1, is going to be negative 2. So I jump down 2 units and then back to the axis. So there's one side of my graph, and it keeps going. And then on the left-hand side, I'm going to kind of follow that same pattern. Down 2 units, back to the axis, up 2 units, back to the axis. And make sure you have a cycle that is repeating itself. And so there would be my function, the sine curve, with an amplitude of 2 instead of 1. In this next one, we have a negative out front and a 2 in front of x. So 2 things happening here. First of all, the negative is a reflection about the x-axis. And then we have a b value of 2, so we're going to have a change in our period. The period is 2 pi over b. Since b is 2, it's going to be 2 pi over 2, which equals pi. So this time one cycle will be a length of pi units. The amplitude, well, a in this case is negative 1. The absolute value of negative 1 is 1. I'm going to start by labeling my axis. This time I want my period to be pi units. So I'm going to make my fourth tick mark pi. Halfway, half of pi is pi over 2. And half of that would be pi over 4. So each little tick mark, my scale on this x-axis, is going up by pi over 4. So I have 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4 is pi. And then I label the same way for our negative values. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. On the y-axis, I'm still labeling 1, 2, 3, negative 1, negative 2, negative 3. Now, our first point for cosine is normally at up 1, but this graph is being reflected over the x-axis. So instead, I'm going to start down 1, below the x-axis, because of that reflection. Now, then I just follow the pattern. So I go up to the axis, up 1 unit, back to the axis, down 1 unit. And that would be 1 complete cycle with a period of pi. And then I do the same thing up, back to the axis, down below on the other side, so that the cycle repeats. You can always graph any function on a graphing calculator. I just popped in a graph from desmos.com where I graphed our regular cosine function and then negative cosine of 2x on the same set of axes. And when we're using the same scale, you can see that in red, my cosine graph, the period is 2 pi, and or the length of 1 cycle. And if you look at the blue graph, negative cosine of 2x, it's reflected about the x-axis, and 1 cycle goes from 0 to pi. So there's actually 2 cycles from 0 to 2 pi. For our next example, we're going to graph y equals 3 cosine of pi over 2x. In this case, b is pi over 2. And the period is 2 pi over b, so that will be 2 pi over 2. And remember, when you divide by a fraction, you multiply by the reciprocal, so that would be 2 pi times 2 over pi. And the pi's are going to cancel out, leaving us with 4. So in this example, 1 cycle will be 4 units long. The amplitude, well, a is 3 in this problem. The absolute value of 3 is 3. So our amplitude is 3. So we're going to label our axes. On the x-axis, since my period is 4, I'm going to make my 4th tick mark 4. And in this problem, every tick mark is going to represent 1 unit. So 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. On the y-axis, I'm still going to label by ones, 1, 2, 3, negative 1, negative 2, negative 3. Now we're ready to graph the function. Cosine usually has a y-intercept at 1, but since we have an amplitude of 3, we're tripling the height of that point. So the maximum point is going to be up at 3. And then we go down to the x-axis, down 3 units, back to the x-axis, and back up 3 units. And that would be 1 cycle. And then we repeat that on the other side. Down, down, up, up. And that pattern would continue. So I'm going to put some arrows here. Our next part is to graph a tangent function. So again, we'll start with the unit circle. If we think about our values from the unit circle, tangent of negative pi over 2, the coordinates at negative pi over 2 are 0, negative 1. And if I do y over x, I get negative 1 over 0, which is undefined. At negative pi over 4, down here, the coordinates are root 2 over 2 and negative root 2 over 2. And if I divide those, I'm going to get negative 1. Tangent of 0 is, since our coordinates are 1, 0, y over x would be 0 over 1, which is 0. Tangent of pi over 4 is 1. And tangent of pi over 2, 0, comma 1, if I do y over x, I get 1 over 0. Again, that's undefined. Okay, so where this graph is undefined, we're going to have vertical asymptotes. So at negative pi over 2, we're going to draw a vertical asymptote. At pi over 2, we're going to draw a vertical asymptote. This tangent is also undefined at 3 pi over 2, at negative 3 pi over 2, and every time you add pi, so 5 pi over 2, 7 pi over 2, and so on, you're going to have a vertical asymptote. So we have vertical asymptotes at x equals negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and so on in both directions. If we plot these other points, I'm going to start in the middle. We have the point 0, 0, so it goes through the origin. If I go over pi over 4, I would go up 1, and left pi over 4 down 1, and the tangent graph goes like this and approaches those vertical asymptotes in both directions. So it's an increasing graph going through the origin, and then we repeat that same pattern. So in the middle of the two asymptotes, I do an x-intercept. In between those, the asymptote and the x-intercept, I go up 1 to the right and down 1 to the left. And this graph will keep repeating. And I only have room for half of 1 right there, but it would keep going. Okay, and then same thing over here. In between the asymptotes and x-intercept, right 1, up 1, left 1, little tick mark, and down 1. And it goes like that. The domain of this function is all real numbers except for those vertical asymptotes. So all reals, but x cannot equal pi over 2, 3 pi over 2, and so on. So we could express that as pi over 2. Every time you add pi, you get another vertical asymptote. So plus pi k, where k is any integer. The range of this function, it goes down forever and up forever, so the range is all real numbers, or negative infinity to infinity. The period of a tangent graph is only pi. It's not 2 pi like with sine and cosine. And when we have a change in period, we're going to use the formula pi over b instead of 2 pi over b. And one more thing about tangent graphs, they technically we don't use the word amplitude, but if you change that value a in the front, like say you had y equals 2 tangent x, that's a vertical stretch by a factor of 2. So the points that are up 1 and down 1 would double their height. So I would double 2 and go double 1 and go up 2 and down 2, and it would still go through the origin. So that would be, it would still approach those asymptotes. So that would be an example of what y equals 2 tangent of x might look like. Now we're going to do an example where we have a change in period. So the period of a tangent graph, b is still the coefficient of x, so in this case b equals 1, 4. But the important thing to remember is that we're going to use the formula the period equals pi over b for tangent graphs instead of 2 pi over b like we did for sine and cosine. So the period of this graph is going to be pi over 1/4, which is the same as pi times 4 over 1, which is going to be 4 pi. So when I label my axes, I'm going to make my fourth tick mark 4 pi. And then in this case, it's going to be 1 pi, or just pi, 2 pi, 3 pi. And same thing on the other side. And on the y-axis, still 1, 2, 3, -1, -2, -3. Now the period of this function is supposed to be 4 pi units, but you want to label your, it needs to go through the origin, and the asymptotes, the distance between the two asymptotes needs to be 4 pi units. So we're going to go from -2 pi to 2 pi, so that the distance between the asymptotes is 4 pi, the period of this tangent graph. And then in my middle tick mark, I go up 1 to the right and left 1 to the left, or left 1 down 1. And then we approach the asymptotes in both directions. And then I can do part of another cycle on the left side, left and right side. This is the right side. And the left side, I would have the upper half. And that would keep going. Here's a graph from Desmos.com that I've edited a little bit, where I graphed tangent x and tangent 1/4 x on the same set of axes. So we can see that y equals tangent of x has a period of pi units, so the distance between the two asymptotes are pi. And when I graphed tangent 1/4 x, one period was 4 pi units, so considerably larger, 4 times as big. So you can see that blue graph, the two asymptotes are 4 pi units apart. In the last part, we're going to talk about some basic translations. I'm sorry this video is so long. So we're going to be shifting our functions to the left and right, which horizontal translations are called phase shifts. And then we're also going to have vertical translations where it shifts up and down. And it follows our basic transformation properties, where if you add or subtract a number on the inside of the function to the independent variable, it's opposite land. So if you had x minus some constant h, that would actually be a shift to the right. And if it was x plus some number, it would be a shift to the left. And then a vertical translation is when you add or subtract a number on the outside of the function. It will shift it up or down. And then in this box, all the transformation properties are put into one place. In this first example, we're going to graph y equals 2 sine of x minus 1. So we have two transformations happening. One is a change in amplitude, and that's coming from the 2. Our a is 2, so the amplitude is the absolute value of 2, which is 2. We don't have a change in period because there's no coefficient in front of x, or in front of that input. So the period is going to be the normal period for sine of x, which is 2 pi. Remember, 2 pi over b, if b is 1, you're just going to get 2 pi. The phase shift, we don't have a number added or subtracted inside by x, so there's no phase shift in this case. But we do have a vertical shift. That minus 1 is shifting the function down 1. Okay, so since our period is still 2 pi, which is what it is for a normal sine graph, I'm going to go ahead and label my x-axis, where my fourth tick mark is 2 pi, and then in the middle, pi over 2, 3 pi over 2. Same thing on the other side. And then on my y-axis, 1, 2, 3, -1, -2, -3. Okay, so now when I plot my points, if it helps, you could graph the function with just the change in amplitude first, and then shift each point down 1 unit, if you want to do it that way. The sine function with an amplitude of 2, it would still start at the origin, go up 2, back to the axis, down 2, back to the axis, and same thing on the other side. So I'm lightly graphing my function. This would be y equals 2 sine of x. So I haven't applied the -1. Now the midline is on the x-axis right now. Since I'm shifting the whole graph down 1 unit, I'm going to start by redrawing my midline down 1 unit. This isn't an asymptote or anything. I'm just kind of using it as a guide for where the middle of my graph is going to be before I plot my points for my final curve. So now I'm going to use an actual thicker writing utensil for my final points. Every point on this graph just moves down 1 unit. So each one is going down 1 unit. And that would be my final answer. And finally, our last example, we're going to graph a cosine function with a phase shift. So the amplitude, I don't have any coefficient written in, so the amplitude is 1. The period is not changing because there isn't like a b value in front of that input. So b is still 1, and my period 2 pi over 1 is still 2 pi. And but we do have a phase shift because we have this number being subtracted on the inside. Now remember, horizontal shifts are, I always call it opposite land. Since it's minus pi over 2, instead of going to the left pi over 2, we're shifting this function to the right pi over 2. And there's no vertical shift because I don't have a number added or subtracted on the outside. So no vertical shift this time. Now, just like in the last example, I'm going to start by graphing the function without the translations. So if there are any changes to the period or amplitude, I would do that in my first step. And then I'm going to take that result and shift it for my second step. So I'm just going to graph regular cosine x. I labeled my axes from 0 to 2 pi once again because the period's 2 pi. And cosine x starts at the point 0, 1, goes down to the axis, down 1, up, up. And there's 1 cycle, and I'll do the same on the other side. So there's my regular y equals cosine x. And now we're shifting this function to the right pi over 2. And I have my, my graph labeled by in increments of pi over 2. So every point that I have is going to shift 1 tick mark or interval to the right. So I'm taking this point, my leftmost point, and moving it to the right pi over 2, which is going to move it over to negative 3 pi over 2. This point on the x-axis moves to the right pi over 2. And so each point is going over to the right pi over 2. And then I connect those points. And I can fill in using the pattern, the point over here on the left-hand side. And that would be the graph of y equals cosine of x minus pi over 2.